Welcome to another episode of this tutorial of making Pong from scratch, and today we're going to look at how to implement some feedback from a user, Kevin Hins. He asked, is there a way to create a delay on the ball after scoring? That's what we're going to be looking in today, and let's jump right in. First, what we're going to do is open up the game controller script, and under here I'm going to create a serialized private paddle and call it left paddle, and copy that over and call it right paddle. And down here in our reset game, let's do left paddle dot reset. I know we haven't created this method yet, but we'll get into it in a second. And then the same for right paddle dot reset. Let's jump into the paddle script and implement this method. So I'll do it down here. Say public void reset, and let's go up here, and in our update you see we have this these three lines that we could easily put into one method. I'm going to do private void, I'm going to say move paddle, and I'm going to move these three lines in there. I'm going to create a private bool up here. I'm going to call it override position, and what this is going to do is it's going to be a condition here. So if we're not overriding the position, I'm going to call move paddle so we can move accordingly. And down here in our reset method, before that I'm going to create a private I enumerator. I'm going to call it reset routine, and I'm going to go in here and do start coroutine, reset routine. And what's going to happen here is we're going to say override position is equal to true, so we want to take over the position of the paddle, and we're just going to say float current Y position is equal to transform.position.y. And let's just go up here real quick and create another variable that is going to be visible in the inspector. It's going to be a float, and it's going to be reset time. And down here, let's continue with our method, and we're going to do a for float, let's call it timer, is equal to 0. I'm going to say timer is less than reset time. I'm going to say timer plus equals time dot delta time. And this is a cool little float, or a cool little for loop that I don't know if you've seen before, but if you could imagine the way they're usually used with to get the index of an array. This is a little bit different way to use a for loop, but it works in our case. And so what we're going to do is we're going to create a float. I'm going to call it target position. That's going to be equal to mathf.lerp. And where are we going to lerp? From our current position, which now that I think of it, this should be our start position. So this is where our movement starts. That's where the position starts. And our target Y is, it would be 0, because when we can take a look at the paddle. When Y is at 0, then it's at the origin. So if we set that back to 0, then it's going to reset our paddle's position. That way, you know, the game starts off with everybody at 0. So we're going to pass in 0, and our T is going to be timer divided by our reset time. And this equation here, timer divided by reset time, works perfectly because this equation is never going to go over 1, and it's going to start at 0 and gradually move up over time because we're incrementing it here every time we run this loop. And that's what mathf.lerp really looks for, is a number that goes from 0 being this variable that's here, and then 1 being here, and anything in between is going to be interpolated. And I hope that makes sense, and that's how we're getting our target position to have it smoothly move back to its starting position. And now what we want to do is apply that to our transform. So we say transform.position, and we can't exactly set the Y by itself. Something to do with C#. I kind of don't get it, but what we have to do instead is make a new vector 3. And for our X, we just pass it what it currently is, which is transform.position.x. And for our Y, we pass in our target position. And our Z, we're gonna, just to be safe, pass in transform.position.z. And so this doesn't run in the same frame, we have to yield return null. All this does is just wait until the next frame until the code can continue running, which is gonna go back into the loop up until it meets the condition. And now to make sure that our Y position gets reset exactly to 0, we're going to do that explicitly at the end of the loop, just in case this number didn't exactly equal 1 to be this number. I hope that makes sense. So we say transform.position, and you can really just copy this over, save you some typing, and instead of target position, we're just gonna get 0 because we know that's our target position. And then at the end, we just gotta make sure that override position is equal to false, so we're giving control back to the player to move it with their keys, or the AI to move on its own. So once you save those changes, go back to Unity and make sure that on our game controller we have our paddles assigned to their respective sections. So left paddle goes to the left paddle, and the right paddle goes to the right paddle. Now on our paddles, we gotta set the reset time, and we could just open the prefab and change it there. So I'm gonna do something like 0.3, and then go back out, and you can see that applied to both of the paddles. And I'm gonna start one off as not an AI, the left one, and see what that looks like. So the paddles reset their position after the game is over. Now we just gotta do a little wait on the ball, and let's take a look at that by opening up the ball script. And for the ball, we're gonna do something similar. We're gonna do private enumerator and call it reset routine, and we'll do the same up here and create a private bool, call it override position, and we're going to set it to true in our coroutine. And then we'll just do a yield return new wait for seconds, and we could pass in a, let's create another float. And this is going to be the same thing, just reset time. Let's go down here and put that in the wait for seconds. And then override position is equal to false. And then let's just go up here and copy this transform.position into this coroutine just to make it a little bit nicer. And then in reset, we can just call our coroutine by going start coroutine, reset routine. And let's go into Unity, find the ball, and give it a reset time. We're gonna do the same thing, 0.3. Now let's hit play and see what that looks like. So I'm gonna get scored on. Well, that's kind of strange. And that didn't seem to work. Let's see what's going on. See here in the fixed update, I forgot to do the whole if override position, or if not override position. Or let's make it easier to read. If override position is equal to false, so we don't want anything overriding our movement. And now that I remember, actually back here we're supposed to, apart from resetting the transform, we have to reset its velocity. So rb.velocity is equal to vector2.0. Let's see what that looks like. And now as you can see, the game is starting a bit more fairly when you gets scored on, everything resets itself and starts over again. So what we're going to take a look at now is, if you could see how the ball serving is kind of unfair. Like if, let's say, this player scored, the ball should be going towards him and not, the guy that got scored on. So let's take a look at that now. So now in our ball script, let's go up here and create a serialized field private float. We're going to call it serve angle. And this is the angle we want to serve at. So let's set it to 45 for now. And we're going to create a method called serve. And we're going to pass in a paddle.side. And I'll just call it side. And here we're going to use some of that trigonometry again. So I'm going to make a vector 2 and call it serve direction. I'm going to set that equal to a new vector 2, and on the x it's going to be mathf dot cosine, and then give it the serve angle times mathf dot degrees to radian. You turn those degrees into radians for this function to work. And on the y, I'm going to pass in mathf dot sine, and then same thing, serve angle times mathf dot degrees to radians. And then we say that velocity is equal to, which is our velocity variable that moves our ball, is equal to serve direction times move speed. And in our game controller, we're going to set a variable up here. It'll be a private paddle.side, and I'm going to call it serve side. And here, right after we check what side scored, we're going to say serve side is equal to side. So we want to serve it to the side that scored. And so down here in our reset game for our ball.reset, I'm going to pass in serve side. And we haven't implemented this yet, but let's go back into the ball. And in our reset method, let's add a paddle side, and we could just call it side. And this is going to go here as well into our reset coroutine, so you can copy that over. After override position, we could do serve and then give it the paddle side, which is just side. And we'll do something later on with side, but for now let's see what that looks like. So hit play, and as you can see, right now it's not really working as you intended. It looks like it is, but if I could score on the other player, you'll see what I mean. Dang, this bot's pretty hard. You see how I served to his side again after I scored on him. So the reason being is because the angle that we served at needs to be flipped depending on who scored. So if we go down here and do if side is equal to paddle side dot left, so the left side scored, then we gotta change the serve direction dot x to be equal to negative serve direction dot x. So it's just pretty much flipping over the direction. And let's go ahead and try that. And for this test, I'm gonna set both of them to not be AI. Let's see what that looks like. So you see that the angle got flipped and now it's going towards the left side. And that's going to the right. And I kind of don't like how it's serving up. So what I'm going to do instead is also flip the y direction regardless of what side it's on. So serve direction dot y dot negative y. Let's jump back in and see what that looks like. Yeah, see, I kind of like having it served down much better. And let's try a different serve angle, like 20. let's see what happens. I see now it's less gradual. And now if we want to make that initial serve also work with our serve code, it's pretty simple. All we got to do is in the start method, instead of this velocity is equal to vector2.left times move speed, we could just feed in the serve method. And we just decide, I'm gonna have the left side be served to every time when the game starts. Let's see what that looks like. Alright, everything seems to be working. And this video is getting pretty long, so I'll just leave it there. Hopefully you learned something new and you got more practice with using angles, with using the cosine and sine function. They can come in really handy, and it's nice to have them and know how they work. And if you got any other suggestions for the next video, I'm thinking of just working on the menu system and getting a menu to show up at the beginning before starting the game, and also at the end of the game when somebody wins. If you have any other suggestions, make sure to leave them down below, and I'll see you on the next one.